Hi everyone, my name is Heinz, like the tomato ketchup, and I'm a software developer in South Africa. I made this video to show you an example of what's possible with Home Assistant. I will show you in this video how to set up your Home Assistant with your Sunsynk or Deye inverter so that you can automatically export to the grid during peak times to earn credits and to import from the grid during cheap times to save on your electricity costs. So before we get started, these are the tools that you will need. Obviously, you need to have a Sunsynk or Deye inverter with a storage battery. You will also need to run your own Home Assistant server, and you will need a smart Deye dongle that allows you to control all the functions on your inverter from Home Assistant, and this comes with a free dashboard. Lastly, you will need a plan from a company such as Octupus Energy that allows cheap import rates and export rates that is worth your while. In this example, we're looking at Octopus Flux that gives you cheap import rates from 2 to 5 in the morning and export rates from 4 p.m. up to 7 p.m. Let me explain how the parts are integrated. Your inverter is connected to the smart Deye dongle via RS485 and Wi-Fi. The smart Deye dongle sends the data over Wi-Fi to your Home Assistant server. All the data is processed and stored on a Home Assistant database and displayed in the dashboard. You can view the dashboard either with your computer or with your mobile phone app. You can also set up remote access to your server and view it from anywhere in the world if you want to. At no point does the data actually leave your network, and nobody can sell your data. You are not at the mercy of any service provider that has got full control of your inverter. There's no cloud service that could potentially go offline. You do not need an internet connection at all. In fact, if you were on a remote island, you could still fully control your inverter and all the functions on your inverter via automations. This is 100% private. You have full control and you own all your data. For me, this is the perfect setup for a smart home. So let's have a quick look at the dashboard. First off, there is the power flow card that updates in real time the state of your inverter. This helps you to see what is currently happening and where power is flowing on your system. The next is a chart of the Octupus Energy import and export rates. Notice that the colors are coded blue for import and orange for export. And then there's also a line that shows where we are currently. It says now. The system timer settings corresponds to the settings on your inverter. Slot 1 is for import or charge, marked in blue, and slot 4 is for export or discharge, in the color yellow. All the other slots are still user configurable and can be customized according to your need. On the grid charge settings, you can edit the state of charge to specify the desired percentage. The grid charge current gets calculated to span over the whole charge window. On the export settings, You can also set the inverter state of charge percentage. Additional, you can specify a reserve percentage. The target state of charge for the export is the inverter state of charge plus the reserve, as shown in the time of use. The export power is automatically calculated and adjusted. The aim is to reach the target within the specified discharge time window. This will ensure that you do not use any grid power once the target is reached. If you have additional power consumption by your house during the discharge window, the export power will also be adjusted on the fly. The automations that run the show are also linked to the dashboard. We have the setting automations. These are triggered when the state machine changes and adjust the inverter settings. And then we have the time trigger. This is the main automation, and it changes the state machine. And then lastly, we have the state machine itself, called Octupus Energy Run Mode. Now if I'm going to open this, there you can actually see a history of when the system was in various states, when it started, when it stopped, and also a history exactly when it went into that state and what actually moved it to that state. Of course, you could manually change this, and that would actually change then settings on your inverter, because the settings automations would kick off as soon as you change the state. So in summary, how this works is there's a time trigger, the energy time trigger. At certain times, we actually change the state machine. Fairly simple. That is then change the Octopus Energy Run mode to a different state. Once it changes to a different state, there's automation for each state, and that automation will then essentially go and it will change settings on the inverter. These four automations over here correspond to states, and the last two are actually to update the discharge rate and the charge current. So over here, the charge current and over here the discharge rate. Okay, so a quick guide how to install the Octopus charge and discharge desktop and all the automations that go with it. So if you go to my GitHub and you look at the standard page, here at the bottom there's a link that says Octopus Flux setup, and this is the guide to install your own desktop. So obviously we've already covered what you need, and let me just highlight this. Step 1, back up your configuration before you start. This means make a full backup and download it locally to your machine. so that you have a point where you can actually restore should things go horribly wrong. So if I look, and this is a demo system, but I'm going to demonstrate on a system. Go to Settings, System, Backups. I want you to go and say create a backup. It must be a full backup, and name it something logical that you will be able to use. I always like to say take the date 6 May and create this backup. Okay, excellent. The backup completed. And what I want you to do is download this backup to your local machine. Next, we're going to have a look at the plugins needed. So, of course, you need the standard dashboard that you have already set up, hopefully, at this stage, when you bought the Smart Deye dongle. So, let's move on to Soulcast PV Solar. And let me say this is optional to some degree, simply because you can use it as an estimate to see what tomorrow's solar is going to be like. If you're not interested in that, you could probably skip this. But anyway, let me show you on the hack store. We look for Soulcast PV Solar. You go to this item and you should be able to download it. It's already installed, so I'm not gonna re-download it at this stage. And like any normal plugin, you will have to restart Home Assistant by going to Developer Tools and say Check Configuration, Restart. I'm going to skip this for now, simply because it's already installed. The second part of it is actually you go to Devices and Services and you say Add Integration. And in this case, you are going to look for Soulcast. The moment when you actually install this, it will ask you for the API key. So for Soulcast, you need to register on the Soulcast website, and you can actually get a free key for a single array, which should be good enough to give you some level of prediction. And afterwards, you should have a service over here called Soulcast. There you go. So that's this plugin. Next is the Octupus Energy plugin. And we also want to go to Hacks. This is Octopus Energy plugin, and you should be able to download it. Once again, not going to do that because it's already installed, and you need to go to Devices and Services. Oh, and Don't forget to restart your Home Assistant before you try to go add the integration. Okay, so when you click on this, it will bring up a screen where you need to put in the API key that you will find on your account, as well as a account ID. So let's say we've installed both these plugins. The next steps would be to install the dashboard on import export. So you go to settings, dashboards, add a dashboard from scratch, import export. You can basically name it anything that you want. So we grab the dashboard, we copy the raw file, we go to the raw configuration editor, and we paste the contents. And of course some things won't be working. So next we go to Studio Code Server, and in the config folder you check if you don't already have packages. You need to create a new folder and call it packages. In my case I already have one, so I'm just going to create a new file. Oh, wrong location. In the packages folder, need to add a new file. Oh. Now essentially you can call this file name anything. You're not forced to use the name that I chose, but I'm going to stick to it to make things simple. Copy the raw file and paste it over there. Next we need the automations. So what we want to do is go to automations, right at the bottom you paste in all the automations. Now the reason why you need to put all the automations in the automations file and not in the packages folder is when you put them in a packages folder you cannot edit them. They will work, but if you want to modify any of these automations you will have to put them in your automations YAML file. And then the last important step is in your configuration YAML file. This line needs to be included. Now what this does is it tells Home Assistant to look on your packages file, and if you remember previously we had lots of entries within the template YAML file. I actually put all of those together in the Smart Dye dongle YAML file now. So technically you could take all those different bits and pieces out and just have one smart Deye dongle file. It is exactly the same. So the config now file now includes this port. Great. We've done this port, and now we need to restart Home Assistant. Very important to actually check your configuration and make sure that we don't have any corrupted config. Let's restart Home Assistant. So if everything started and all the entities are defined, then hopefully this menu will actually populate. Oh yes, this is not populating simply because if you go edit it, the Octupus Energy entities actually contains your account number and meter number. So you will have to use Control Spacebar and just find out exactly what is the correct numbers that need to go in there so that it matches the current day rates. And once you fill them in, your graph will start populating. Also, let's see, next important steps. So let's quickly change the state to be disabled. And we also want to disable the automations, the time trigger, as well as all the other automations. Set up your inverter with the config items. The times for time zone 1 and 4. So what you would do is you would go edit this time and change it to be 2 o'clock to 5 o'clock. As well as change this time slot from 1600 to 1900. So we've set up these two time slots now. Setting up your desired state of charge for charging. So the charge manual options, you can set up your desired charge. For example, if you want to charge your battery up to 70%, I'm going to leave mine on 66%. And also you could, the solar forecast for tomorrow might give you a good indication as to how high you want to charge your battery. Set up your state of charge for time zone 4, which is this charge. So you want to specify to what percentage do you want to discharge your battery. For example, 30%. And then we need to set some reserve. I'm going to set 12% reserve, which will give me 42% to discharge my existing battery down to 42% in this time slot. So we've done the discharging. We set up a reserve percentage, and now that everything is starting to look good, I guess we can enable the automations again. So let's enable all the automations, and the run state is currently still marked as disable. What you could do now is we can put it in a normal state, which means that if it's in a normal state, then the time trigger will be able to change it to the next state when we get to that time slot. Great, there we have it, all running. Done with the dashboard. I got up at some crazy hours of the night so that we can see how the system actually performs. So let's go. 835. So let me show you how the automations actually run the system now. It's now 1:59 AM and we're about to get the start charge kickoff. So there's a 15-second delay before the settings get written to the inverter, and then we will see the inverter ramping up the currents and actually charging the battery. There you go, 50 amps. $80 amps, and the battery is busy charging. It is now just after 5 in the morning and charging has stopped. We passed the charging time window and there's not a lot to see except that the state is now stop charge. Probably the most important thing to notice is that the battery has been charged to 90%, and that is the target that was specified on the system time settings, time zone 1. 835. It is now just before 4 PM and we're about to start the discharge to the grid. Just a couple of quick notes about the state of the system. As you can see, the battery is on 99% and still absorbing a little bit of power, and then we're actually having good solar today, so most of the solar power actually gets exported because the battery is full and there's nowhere else for the power to go. So let me quickly zoom out, and we're gonna watch the state machine as it actually switches over. There is about a 15-second delay for the automation to trigger the settings on the inverter, Now have a look at the battery and at the grid numbers. And there the export starts. At this stage we're exporting 5 kilowatt, which is essentially 3 kilowatts from the battery, as well as the existing solar that's coming in of 2.5 kilowatt. So sending close to the limit back to the grid. It is now just before 7 p.m. and we are at the end of our export session. If you look at the Octupus Energy run mode, that should change any moment now. And of course there's a 15-second delay. Notice that we discharged to 35%, which is exactly the 20% plus 15. So let me give you quickly another view of the history of how the system actually ran and charged the battery and discharged the battery. Let's quickly go to the graphs and I'll zoom out a bit. Zooming in on the graph, you can see where the charge went up and down, how the system actually discharged and the solar contribution during the day. It looks like it's working really well. Please post your questions in the comments, and if there are some topics that I haven't explained well, perhaps I can make a follow-up video to this one. I would love to get your feedback and ideas. Thank you for watching.